All right, get ready because today we're going deep on something pretty mind-bending.
Oh, yeah.
Quantum entanglement.
Okay.
You
Yeah.
know, that spooky action at a distance.
Right.
Even Einstein
Yeah.
had a hard time
Yeah.
getting his head around it.
Sure.
Turns out this phenomenon
Mhm.
is actually like the foundation for some seriously groundbreaking technology.
Wow.
Especially when we're thinking about quantum computing.
Okay.
So we're going to be exploring this really fascinating world
Okay.
by kind of unpacking the key insights from a systematic review
Okay.
called The Role of Quantum Entanglement in Advanced Quantum Computing Systems,
Mm-hmm.
and then also an article called Quantum Entanglement, where physics meets philosophy in the quest for computational supremacy.
Sounds good.
But I think before we get too far,
Yeah.
let's just break down like what quantum entanglement is.
Yeah. So what's fascinating about quantum entanglement is that it demonstrates this profound interconnectedness between two particles.
Okay.
So imagine two coins flip simultaneously.
Yeah.
One lands heads,
Yeah.
the other tails, right?
Right.
Not in the quantum world
did.
with entangled particles.
Yeah.
If one is heads, the other is guaranteed to be tails,
Whoa.
no matter how far apart they are.
Really?
They're linked in a way that really defies our classical understanding of physics.
Okay, so it's like these two particles are having a secret conversation.
Yeah.
Across huge distances,
Right.
instantly knowing what the other one's doing.
Exactly.
I'm starting to see why Einstein called it spooky.
Yeah.
You mentioned that these sources we've got,
Uh-huh.
they lay out how this seemingly bizarre phenomenon is being used to build quantum computers.
Yeah.
Can you give us a little bit of like the historical context? How
Yeah.
did we get from Einstein's skepticism
Yeah.
to entanglement being at the forefront of quantum computing?
So Einstein famously doubted quantum entanglement,
Right.
called it spooky action at a distance,
Yeah.
because it seemed to contradict his theory of relativity.
Oh, interesting.
But over time, numerous experiments have confirmed that it exists.
Okay.
And what's really interesting is that for decades,
Yeah.
entanglement was mostly theoretical,
Uh-huh.
a topic debated by physicists.
Huh.
But recent breakthroughs have brought it into the realm of practical applications.
Wow.
For example,
Yeah.
scientists have successfully entangled systems with more than 20 qubits.
Okay.
The building blocks of quantum computers,
Uh-huh.
they've even demonstrated quantum teleportation,
Ah.
transferring quantum information over distances of 100 kilometers.
Seriously?
Using entanglement.
Teleportation. That sounds like straight out of Star Trek.
It does.
But how does this actually work? How
Yeah.
does entangling these qubits lead to the creation of like a powerful quantum computer?
The power of quantum computers really lies in their ability to exploit the principles of quantum mechanics,
Okay.
specifically superposition and entanglement,
Mm-hmm.
unlike classical computers that use bits,
Right.
which can be either a 0 or a 1. Quantum computers use qubits.
Okay.
Because of superposition, a qubit can be both 0 and 1 at the same time.
Wow.
Now imagine entangling two qubits.
Yeah.
They become interconnected,
Uh-huh.
forming a single system that can explore multiple possibilities simultaneously.
Oh, wow.
This is what gives quantum computers their incredible potential.
So if I'm understanding correctly,
Yeah.
instead of being limited to like a single value, like a
Yeah.
regular computer bit,
Uh-huh.
these entangled qubits are like spinning coins,
Yeah.
existing in multiple states at once,
Very
allowing for
so.
just a massive amount of parallel processing.
Precisely.
Okay.
And this quantum parallelism, as it's called,
Right.
allows quantum computers to tackle problems that would take classical computers,
Yeah.
even the most powerful ones,
Right.
billions of years to solve.
Wow.
This opens up possibilities in fields like drug discovery, material science,
Okay.
and even cybersecurity.
So those applications sound incredible.
Yeah.
But how exactly would quantum computers revolutionize these fields?
Okay, so give me some like concrete examples.
Take drug discovery, for example.
Okay.
Quantum computers could simulate the complex interactions of molecules
Okay.
at an unprecedented level of detail,
Wow.
accelerating the development of new drugs
Okay.
and personalized medicine.
Oh, wow.
Imagine medications tailored specifically for your genetic makeup.
Wow, that would change healthcare as we know it.
Right.
So no more one-size-fits-all approach to medicine.
Exactly.
And what about material science? What
Yeah.
kind of breakthroughs could we see there?
Imagine designing materials with specific properties,
Okay.
like superconductivity or extreme strength,
Uh-huh.
by manipulating matter at the atomic level.
Really?
This could lead to more efficient solar panels,
Wow.
lighter and stronger building materials,
Interesting.
and even revolutionary new fabrics.
This all sounds pretty futuristic.
It does.
But I have to ask,
No.
if this technology is so powerful...
What's holding it back?
Yeah, that's a great question.
There must be some challenges to harnessing this quantum power, right?
We're absolutely right.
Okay.
One of the biggest hurdles is decoherence.
Okay.
These entangled states,
Yeah.
while powerful,
Huh?
are incredibly fragile.
Real.
The slightest interaction with their environment,
Oh, interesting.
even tiny vibrations or temperature fluctuations,
No.
can cause them to collapse,
Oh, no.
losing the
Yeah.
quantum information they carry.
So it's like trying to build a house of cards in a windstorm.
Yes,
Maintaining these entangled states must be incredibly difficult.
it's a huge challenge
Yeah.
to make these systems work.
Right.
We need incredibly controlled environments,
Uh-huh.
temperatures near absolute zero,
Wow.
which is colder than outer space,
Oh, my goodness.
and incredibly precise control over quantum operations.
Really?
And that's just the beginning.
Okay, so it's clearly not as simple as just plugging in a quantum computer and hitting go. What are some of the solutions
Whoa.
that scientists are exploring to kind of overcome these hurdles?
Yeah.
I know the systematic review we have
Mm-hmm.
goes into some of the promising advancements in this area,
Yeah.
particularly with what's called topological protection.
Yes. Topological protection is a very exciting area of research.
Okay.
It's about using clever geometric arrangements of qubits
Okay.
to essentially shield them from environmental noise.
Interesting.
Think of it like creating a fortress around your entangled state,
Okay.
protecting you from disruptions.
Uh-huh.
One approach mentioned in the systematic review is using surface codes.
Okay. Surface codes, quantum fortress.
Yep.
I'm getting some serious sci-fi vibes here.
I know, right?
But I need you to break it down for me.
Sure.
How do these surface codes actually work?
So imagine a grid or a lattice structure,
Okay.
and each intersection point on that grid
Uh-huh.
represents a qubit.
Okay.
By cleverly arranging and manipulating these qubits on the surface,
Uh-huh.
we can create a protective barrier.
Right.
That makes the information encoded in those qubits
Yeah.
much more resistant to noise.
Oh, interesting.
And the results have been quite promising.
Okay.
The systematic review highlighted studies where coherence times, a measure of how long these entangled states last,
Right.
have increased by an average of 47% thanks to surface codes.
That's a huge leap forward.
It is.
But even with these protections,
Mm.
errors can still happen, right?
You're right.
Yeah.
No system is perfect.
Right.
But researchers are developing sophisticated error correction protocols
Uh-huh.
to deal with these inevitable errors.
Okay.
The systematic review found that new protocols have reduced the number of qubits needed for error correction
Okay.
by 28%.
Wow. So we're making progress on both fronts.
We are.
Protecting the qubits and
Yeah.
correcting errors.
Exactly.
But I'm curious,
Yeah.
this source, quantum entanglement, where physics meets philosophy in the quest for computational supremacy, takes a different approach. It dives into like the philosophical implications of entanglement.
Yeah.
Can you tell us a little bit about that?
This article raises some really thought-provoking questions.
Like what?
Are we simply building complex machines,
Mm-hmm.
or are we tapping into something much deeper?
Yeah.
The universe's inherent ability to compute.
Wow.
It delves into the idea that perhaps we're not just manipulating particles,
Right.
but interacting with the fundamental fabric of reality itself.
Whoa, that's getting pretty deep.
I know, right?
Are we becoming more like observers?
Potentially?
Harnessing the universe's computational power
Yeah.
rather than creating it?
It's a fascinating concept to consider.
It is.
This blurs the lines between physics and metaphysics and forces us to re-examine our understanding of reality,
Yeah.
consciousness, and information.
All right, my brain needs a minute to process all of this.
Yeah, it's a lot.
This is a lot to take in,
It is.
but it's absolutely captivating.
Oh, for sure.
We've covered so much ground already, but we've only just scratched the surface.
Right.
Before we dive into like the broader implications of all of this.
Yeah.
Let's take a pause here.
Sounds good.
We'll be right back after a short break.
Yeah. It really does make you think.
It does.
Question everything.
Yeah.
When you start thinking about those philosophical implications of quantum entanglement.
Yeah, for sure.
But I think it's important to consider like both
Right.
the scientific advancements
Yeah.
and the philosophical questions that come up
Totally.
because of them.
It's a powerful reminder that the pursuit of knowledge
Right.
often leads us down these paths
For sure.
that we didn't expect.
Totally.
But let's bring it back down to earth for a minute.
Okay.
We've talked about the potential of quantum computing
Yeah.
and the challenges that scientists are facing.
Right.
But, like, what does this all mean for
Yeah.
you, the listener? In the coming years,
Yeah.
should we be expecting quantum computers in our homes anytime soon?
Well, not exactly in our homes.
Okay.
At least not in the near future.
Right.
These machines require highly specialized environments and expertise to operate.
Okay.
But the impact of quantum computing will be felt across many different industries,
Okay.
which will indirectly affect all of our lives in profound ways.
So paint me a picture.
Okay.
What might a future shaped by quantum computing look like?
Okay.
What concrete changes can we anticipate?
Imagine a world where personalized medicine is a reality.
Okay.
Quantum computers could simulate the complexities of biological processes, leading to the development of drugs tailored to an individual's genetic makeup, revolutionizing healthcare as we know it.
That would be incredible.
Right.
No more guessing which treatment might work best.
Yeah.
It would be like having a medical solution designed specifically for you.
Exactly.
What about other fields? What other areas could see major transformations?
Material science is another field ripe for disruption.
Okay.
Quantum simulations could help us design entirely new materials.
Wow.
With properties we haven't even dreamt of yet.
Seriously.
Imagine super efficient solar panels that can harness energy like never before.
Wow.
Lighter and stronger building materials that could revolutionize architecture.
Yeah.
Or even fabrics that can change color on demand.
Okay, now that's just cool.
Right.
It sounds like we're talking about a level of technological advancement that could reshape our world.
It really could.
In ways we can barely imagine.
Yeah.
But this all sounds very futuristic.
It does.
When can we realistically expect to see these advancements become a reality?
It's difficult to give a precise timeline.
Right.
Because the field is evolving so rapidly.
Sure.
But we're already seeing significant progress.
Okay.
Companies are investing heavily in quantum computing research. And governments around the world are recognizing its strategic importance.
Yeah.
I think the next decade will be crucial in determining how quickly these technologies mature.
Okay.
And become commercially viable.
So we're standing at the precipice of a technological revolution.
I think so.
But there's still a lot of uncertainty about the timeline.
Yeah.
What are some of the factors that could either accelerate or hinder the progress of quantum computing?
One crucial factor is the development of more robust and scalable hardware.
Okay.
Right now, quantum computers are extremely sensitive to their environment.
Yeah.
And require highly specialized facilities to operate.
Right.
Making them more stable, less prone to errors, and easier to scale up will be key to their widespread adoption.
So are we talking about a similar trajectory to the early days of classical computers?
Yeah.
Where they took up entire rooms and required constant maintenance?
Yeah.
When will we have a quantum computer that can fit on a desk, let alone in our pockets?
It's a good analogy.
Yeah.
We need to miniaturize the technology and make it more accessible before we can see applications in everyday life.
Okay.
Another key factor will be the development of quantum algorithms.
Specifically designed to take advantage of these machines' unique capabilities.
So it's not just about building better hardware, but also about figuring out how to program these quantum computers to solve real-world problems.
Precisely.
Okay.
We need talented software engineers and computer scientists
Yeah.
who can develop these algorithms and unlock the true potential of quantum computing.
Right.
And of course, we can't forget about the ethical implications.
Oh, yeah, for sure.
As with any powerful technology, we need to carefully consider its potential impact on society, both the positive and the negative.
That's a crucial point.
It is.
We need to be having these conversations now.
Yes.
To ensure that quantum computing is used responsibly and ethically.
Absolutely.
What are some of the potential pitfalls we should be aware of?
One concern is the potential for job displacement.
Okay.
If quantum computers can automate tasks currently done by humans, there could be significant economic disruption.
Another concern is the potential for misuse.
Okay.
Imagine the implications if a malicious actor gained access to a powerful quantum computer.
Right.
They could crack encryption codes.
Wow.
Manipulate financial markets.
Yeah.
Or even disrupt critical infrastructure.
That's a sobering thought.
It is.
It sounds like we need to be thinking about safeguards and regulations now to prevent those worst-case scenarios from happening.
Absolutely.
Okay.
It's crucial to establish clear guidelines and ethical frameworks for the development and deployment of these technologies.
Yeah.
This will require collaboration between governments, industry leaders, and researchers to ensure that these powerful tools are used for good and not for harm.
It's a lot to take in.
It is.
I'm feeling a mixture of excitement and apprehension about the future of quantum computing.
Yeah.
It has the potential to solve some of humanity's greatest challenges.
For sure.
But it also comes with significant risks.
Right.
That we need to address proactively.
Absolutely. I think that's a very astute observation.
Yeah.
And it highlights why conversations like this are so important.
Right.
The more we understand about quantum computing, its potential and its challenges, the better equipped we'll be to navigate this new technological landscape responsibly.
For sure.
Hopefully this deep dive has sparked some new questions or ideas for you.
It certainly has for me. It's given me a whole new perspective on the interconnectedness of things, both scientifically and philosophically.
Yeah.
But before I spiral into an existential crisis, let's bring it back to the core idea of this deep dive.
Okay.
Quantum entanglement.
Yes, that seemingly bizarre phenomenon that's driving such incredible advancements in the field of quantum computing.
It's amazing to think that something that once seemed like pure science fiction is now on the verge of transforming our world.
It really is.
It really makes you wonder if we can harness the power of entanglement to solve such complex problems here on Earth. What other mysteries of the universe might it help us unlock?
That's a fantastic question.
It is.
And it's one that researchers around the world are actively exploring.
Yeah.
The beauty of science is that every answer often leads to even more questions.
Right.
Pushing us further down the path of discovery.
Yeah.
Who knows?
Yeah.
Maybe the answers to some of these deeper questions lie within the realm of quantum entanglement itself.
Okay, my brain is officially full.
I know, right?
But in a good way. Yeah. This has been an incredible journey into the mind-boggling world of quantum entanglement and its impact on quantum computing.
Absolutely.
But before we wrap up, I have one final thought-provoking question for you, our listener, inspired by everything we've discussed today. So if we can use the power of entanglement to solve these complex problems here on Earth, could it also help us unlock a deeper understanding of the universe and our place in it? Is there like a cosmic connection? We're just starting to understand.
It's something to think about.
It is.
As we continue exploring this fascinating world of quantum entanglement and the advancements in quantum computing.
Well, on that note, I think it's time to wrap up our deep dive into quantum entanglement.
Sounds good.
It's been quite a journey.
It has.
Exploring everything from the fundamental principles to the just mind-boggling implications for the future.
Absolutely.
It's always so fun to explore these complex topics.
And I agree.
With you.
Yeah, it's been great.
Hopefully our listener is walking away.
Yeah.
With a newfound appreciation for the strangeness. And beauty of quantum mechanics.
Totally.
And its potential to reshape our world.
For sure.
Absolutely.
Yeah.
And to our listener, we encourage you to keep exploring this fascinating topic.
Yes, definitely.
There's so much more to discover.
Absolutely.
And who knows? Maybe you'll be the one to unlock the next big breakthrough in quantum computing.
That would be awesome.
Or unravel the deeper mysteries of the universe.
Yeah.
Until next time.
Yes.
Keep asking those thought-provoking questions.
Absolutely.